Hey guys, this is Kodishwaran. Welcome to the AWS tutorial video from Intellipaat. Before moving on with the video, let me introduce you to what we are going to learn today. At first, we'll see what was there before the cloud, how the companies used to work and run applications on the internet before cloud. After that, we'll see what is cloud computing and its advantages. Then we'll move on to Amazon Web Services. We'll see what is Amazon Web Services, then why AWS is successful and the future scope of AWS and its job trends. Then after seeing that, we will move to the technical aspects of AWS. That is, we'll look at the service domains and the services which AWS provides. After seeing that, we will see the pricing models of Amazon Web Services. And at the end, we are going to migrate our local application into the AWS infrastructure. We are going to create a whole application and going to host it on the internet. And I already told you at the end of the video there is going to be a quiz, and you can check your knowledge in that by reviewing all the collected points which you have learned from this entire video. Now let us move on with the tutorial video. To start this with, before the rise of cloud. So what was the approach to run an application on the internet before cloud? How do they run it? How were they running it? Let me give you a brief about that. So the first thing a company does is they buy stacks of servers and hardware components. The second thing is they have to maintain and upgrade the servers and databases and the hardware components according to their needs. Then they have to keep on monitoring and reporting it. They have to have reports in order to upgrade or downgrade the softwares and the hardware. And finally, they have to consider traffic of their applications or their websites in order to scale. Then finally, they have to recruit top security professionals so that they can handle incoming unauthorized accesses and threats. It sounds tiring, right? Okay, now let me tell you what are the disadvantages of on-premise setup. The first disadvantage is maintenance of servers. To maintain servers, you always need professionals who can maintain the servers 24/7. Then there will be an increase in expenditure every time you upgrade your hardware, because in a on-premise setup, most of the time when your websites or applications traffic goes down, your hardware components will be idle. When they are idle, it is total waste of money and total waste of time to have those many hardware components. And also it increases your expenditure because you have to maintain all of the hardware components which are not even in use. Then data privacy and security is poor because whole data privacy and security system and the control is in your hand. The company has to provide data privacy and security. It's not going to be in a third party's hand, it is going to be in the same company's hand. Then scalability and flexibility. So what is scalability is that when the traffic goes higher down, it should automatically or manually scale up or down according to the needs. But in an on-premise setup, scaling up is very easy, but scaling down is not that easy. Okay, now moving on. Let me introduce you to cloud computing. Let me first tell you what is cloud computing, then I'll give you more explanations on its advantages. So, in the simplest terms, cloud computing is a technology where a resource is provided as a service through the internet to a user. It can be anything. For example, Google provides Google Docs, Google Sheets through the internet. And it is a software which is provided through the cloud, and that softwares are hosted in Google's personal cloud platform, which is GCP, Google Cloud Platform. Okay, now moving on to the cloud computing benefits. The first benefit is better data privacy and security. AWS or any other cloud provider like Azure or Google Cloud Platform will always hire top security professionals because they have their own products running on their cloud servers. Second is no maintenance worries. You just have to pay the subscription fee or the money which you are going to take for the particular services. You don't need to worry about maintenance of those hardwares. All of the maintenance will be taken care by the cloud providers. Third is faster data recovery. You can store your data in multiple points, like you can store your data in US and UK. So when your main server's data or main database data is lost, you can take the data from some other location and recover it even faster than you expect. The fourth point is scale dynamically. So scale dynamically is very simple. It is auto scaling. That means whenever your websites or applications traffic increase, the system automatically scales up your hardware components. And when the traffic goes down, it scales down your hardware components. And you just have to pay for the particular hardware components which are running currently. Then finally, reduced costs. All the businesses needs to reduce their costs. They always want to cut expenses. So using a cloud provider or using the cloud computing technology makes it very easy so that they can cut maintenance costs, they can cut cost of security professionals, and also the scaling process is seamlessly very easy. So next is, what is AWS? We all know that AWS is a cloud computing platform. That is, AWS, Amazon Web Services, is a cloud provider which provides a lot of services on the internet to the user. Many companies like Netflix, Unilever, Expedia are using Amazon Web Services for their own personal needs. Netflix have went all into AWS. That means all of their infrastructure right now depends on AWS. So think of AWS's capability. Now let me give you a few examples of other cloud providers. The first one is Microsoft Azure. Azure is owned by Microsoft and they also host their own products on it, like Office 365, and also you can do native integration of IDEs like Xcode, IntelliJ IDEA, and Visual Studio. Then Google Cloud. We all know Google is the biggest brand name in the internet industry. Google Cloud came around 2011 and it has become a hit, and it is now the third most popular cloud provider in the world. Alibaba Cloud. We all know Alibaba. Alibaba is a China-based company. Alibaba Cloud is also called as Aliyun. It basically provides services to businesses who want to host their services online. Next is IBM Cloud. IBM Cloud is also similar to Azure, Google Cloud, and Amazon Web Services. It also provides services like compute, networking, and storage services. Then comes VMware. VMware is a software virtualization company. So basically they provide virtual machines via the internet to users or companies. Finally, Salesforce. Salesforce is also a cloud platform and their main tool is CRM, that is Customer Resource Management, and they are considered to be the number one at it. So why is Amazon Web Services so successful? They have started AWS in the year 2006 and it is still the number one cloud platform. Let us see why. Before even a cloud company thought of it, Amazon Web Services already revolutionized the IT industry by introducing a new way to use servers to the companies and the businesses. And there are three key points which made AWS successful. The first is its simple and per hour billing. The billing system of AWS is very simple, that you will be only charged for the particular services which you use, and it is also based on the number of hours you use, not the days or the months. The second reason is Amazon's brand name. Amazon.com is a household name all over the globe because it is the biggest e-commerce platform. Third reason is its easy profile setup. The first thing you have to do is provide your details, your email address, your username and password, just like you create a social media profile. And the second step is you have to give your credit or debit card details, and that's it. Your AWS profile has been set up. But what makes Amazon or Amazon Web Services peculiar? So Amazon has its own leadership principles and it makes its employees follow that. Let me give you a few examples of them. The first is customer obsession. Customer obsession is that leaders start with the customer and work backwards. The first thing they follow is they need the customer's wants. That means whatever the customer wants, they want to give. Then they work backwards. They reverse engineer. The second is invent and simplify. Leaders expect and require innovation and invention from their teams and always finds way to simplify. They also need inventions and also they need to simplify it. The simplified, most easiest user-friendly manner is more attractive for a customer. Third principle is ownership. Leaders or owners, all the employees in AWS or Amazon need to have that feeling of ownership. And the fourth point, this point is common for anybody. So learn and be curious. Leaders are never done learning and always seek to improve themselves. So always keep on learning and be curious in what you do. The next is the future of AWS. So what is going to be the future scope and the job trends of AWS? Let us see. So the market share of 2018's quarter 4, that is the last 3 months of 2018, Amazon Web Services had 32.3% of the cloud computing share, and Microsoft Azure comes second with 16.5, which is almost the half of Amazon Web Services, and then Google Cloud Platform, and then Alibaba Cloud, and after that comes the other services, other cloud providers like IBM Cloud, VMware, and Salesforce. And what are the AWS job trends right now? Let me give you few job trends. So the 4 job trends are AWS SysOps Administrator, Cloud Developer, AWS Solutions Architect, Cloud Software Engineer. So the salary of AWS SysOps Administrator is $111,000 to $160,000, and the Cloud Developer is $95,000, and an AWS Solutions Architect salary varies from $98,000 to $150,000, and a Cloud Software Engineers varies from $63,000 to $93,000, and these are all the numbers for a fresher. The salaries may vary with your experience. If you are an experienced person in the cloud industry or in AWS, you might be earning more than this. This is just the starting. Okay guys, now we've come to the most technical part of AWS. The AWS service domains and the services they provide. The AWS service domains are vast, but let me give you few of them. So few of the service domains are compute, database, storage, migration and transfer, customer engagement, security, identity and compliance, management and governance, and networking and content delivery. Before starting off with explaining the services, let me be sure that the explanation of each of the services will be very simple that anybody watching this video could understand it. The first service domain which we are going to see is compute services. Under compute services, there are a lot of services, but right now we are going to see only 4. These are the most important ones. First is Amazon EC2, then Elastic Beanstalk, then Amazon Lambda, and Elastic Load Balancing. First we'll see what is EC2. EC2 is one of the most integral parts of the AWS ecosystem. It allows users to rent virtual computers on which they can run their own computer applications. Also, EC2 is providing on-demand scalable computing capacity in the AWS cloud. So, for example, if you own Macintosh and if you want to run a Windows application on it which is not compatible with your computer, instead of buying a laptop or a new desktop, you can just opt for a virtual machine on the AWS cloud in which you can run your Windows application for a short time and pay only for what you use. Also, this illustration says that you can also increase your system specifications or rent multiple virtual machines on the same specifications. Moving on to the next service. The next service is Elastic Beanstalk. With Elastic Beanstalk, you can quickly deploy and manage applications in the AWS cloud without having to learn anything about the infrastructure that runs those applications. For example, if you want to run a PHP application and you don't know anything about PHP, you just have the PHP project folder, you can just upload it to the Elastic Beanstalk. It will automatically take care of launching it. It will give you an URL which you can click and see whether your application is working or not. So let me give you a brief summary of what happens here. First, you create an application, whichever platform which you want, like Ruby or Python or PHP. Then you upload that project folder here, and after that you launch the environment. Then the final thing you have to do is manage the environment, because you will be provided an URL which the application will be running on. Then after that you can update your software and keep on uploading the updated versions, and it will automatically get updated. You need not have any technical knowledge or programming knowledge to use Elastic Beanstalk. Now moving on with the next service. The next service is AWS Lambda. AWS Lambda is a compute service that lets you run code without provisioning or managing servers. So look at this illustration below. Okay, now you're on an e-commerce website. Take it as Amazon.com, and you're confirming a package order. So that package order details will be stored in a database. Take it as DynamoDB. And at that time, the Lambda will be triggered. The Lambda runs a data transformation code which is loaded into the Redshift warehouse. Let me explain what are DynamoDB and Redshift in the later parts of the video. But right now, learn what is Lambda. So Lambda runs this data transformation code or whatever code you put into it. And finally, after it is stored in the data warehouse, it will be giving you analytics which are created from those data which you have collected. So this is what Lambda does. The last service in the compute service domain is elastic load balancing. Elastic load balancing distributes incoming application or network traffic across multiple targets such as Amazon EC2 instances, IP addresses in multiple availability zones in many geographic regions. So look at this illustration. There are users trying to use the application and the ELB is in the center of it. So what basically happens is when there are 10 users trying to use a website, the traffic will be less. So ELB will target them or redirect them to a particular EC2 instance. But what if 100 people are trying to access the same website at the same time? The traffic increases. So the ELB divides the 100 people into 10 groups and redirects them into 10 different EC2 instances so that they have easy interaction with the web server without crashing it. The next service domain is database. Database gives us a lot of services in Amazon Web Services, and right now we are going to see 4 of the most important database services. The first one is RDS, then DynamoDB, then Redshift, and finally Elasticache. Now let us see one by one. The first one, RDS. It's Amazon Relational Database Service. It is very easy to set up, operate, and scale a relational database in the cloud. And Amazon RDS provides you with 6 different options. The first one is Amazon Aurora, then MariaDB, then PostgreSQL, then Microsoft SQL Server, MySQL, and Oracle Database. So what can you do with these? So basically, if you want a SQL service or a database service, you could opt any one of these database services like MySQL or Oracle Database and use those services like they are in your local system. Now let us go on to the next service. It is DynamoDB. DynamoDB is a database provided by AWS. It is a key value and document based database that delivers single digit millisecond performance at any scale. That means single digit millisecond performance means it gives you a very low latency. That is, it provides a very fast database communication system. So now imagine there is a social media stream in real time is coming into your application or your website. So there is a Lambda code which you would have written for generating hashtags. So basically think there is a hashtag and there are a lot of tweets coming in that particular hashtag. So what do? That Lambda is triggered, then finally all those data can be stored in DynamoDB. After storing them there, you could take it out or you could use those data whenever you want to create a trend and put it in your application or your website. DynamoDB is used in web, mobile, gaming applications and also in IoT because of its low latency. Now moving on with the next service. Amazon Redshift is a fast, scalable data warehouse that makes it simple and cost effective to analyze all your data across your data warehouse and data lake. So what is the data warehouse? Data warehouse is like a database, but here you can use it to store raw data and analyze data, and it is mainly used to take business or management decisions. So go into this illustration. So check out, first there is an input, then there is an S3 bucket to store that data which is inputted. Then after that there is Redshift. So what Redshift does here, it stores all the raw data inside. Also it has elastic resize and concurrent scaling. These are few of its attributes. So assume that you are storing a large amount of data and you still need more data space stores so that you can store more data. So what elastic resize does it automatically or dynamically resizes or scales your space. Or if you need only to store a less amount of data than you usually do, then it automatically reduces the size. So after doing all these, you can create an analyzed output for business decisions using business intelligence tools. Now moving on to the final service in the service domain. The final service is Elasticache. First of all, let me tell you what is a cache. Cache is an auxiliary memory for high-speed data retrieval. So how does a cache or an elastic cache provide high-speed data retrieval. So basically the cache or an elastic cache is between the two sides. That is, one side is the user end, which contains the internet applications or the web applications, and in the other side is the server side. So whenever the user wants any information or data or a service, he requests, and first it checks in the cache whether it is available or not, and if it is available, it will be directly taken to the user. But if it is not, then it will go to the server and come back. So if the same information or data is used frequently by the user, it will be automatically stored in the cache, and the next time he uses it, it will be there. And also in Amazon Elastic Cache, there is an option that you can scale up or down dynamically. Moving on to the next service domain. The next service domain is storage. Storage also has a lot of services. Storage is one of the main features which is used by companies and firms who are using AWS. Take Netflix or Expedia. So what they do is they rent the infrastructure from AWS and they store all of their components, all of their informations, all of their data in AWS storage services. But the data is not owned by AWS. Only the services which they provide are owned by AWS, and the data is totally in control of the company who is offered that. Okay, now let us see the first storage service, Amazon S3. Amazon Simple Storage Service, or Amazon S3, is the first service under the storage service domain. So it is an object-based storage, and it offers a high scalability and data availability and a very good security and also performance. So what you can do with this storage services, if you are a user, you can create a storage bucket and then upload your files and also store it there for how much ever time you want, and then you could download it. It basically is stored in the internet, and the objects which you are storing, like image files or video files, are called objects, and those are stored inside buckets. So the next service under the storage service domain is Amazon S3 Glacier. Amazon S3 Glacier is basically used for archiving data and backing up data. Many companies use Amazon S3 Glacier because of its very low cost service. It is very secure and also durable, and you can use this for a long-term backup. If you want to back up your data for the next 10 years, Amazon S3 Glacier is your right option. And let us now move on to the next service under the storage service domain. The next service is Amazon EFS. EFS is nothing but an elastic file system, and it provides a simple scalable elastic file system for Linux based workloads. That means you could create file systems and mount it to your EC2 instance, and you could use it as an elastic file system or a normal file system, and also you could create a single EFS or a single elastic file system and mount it to multiple EC2 instances. And when you change in a particular EC2 instance, and when you upload a file to the EFS in a particular EC2 instance, it will be updated in all the EC2 instances. That is because the EFS is a single entity and there are 10 EC2 instances, and the same EFS instance is connected to the 10 EC2 instances. And you could use EFS to test and optimize and then move data and finally share data between instances. Now let us see the last storage service domain, storage service under the storage service domain. The last storage service is AWS Storage Gateway. AWS Storage Gateway is an actual gateway between the on-premise software appliance and the cloud-based storage. So what AWS Storage Gateway does is, it is the intermediate or the middleman for the on-premise application and the AWS cloud infrastructure. So whenever an on-premise application is opted for AWS cloud infrastructure services, AWS Storage Gateway leads the way. So what it does is, it gives a seamlessly easy integration with data security features between both the on-premise IT environment and the AWS storage infrastructure. So this is all about the storage service domain. Now let us move on with the next service domain. Networking is the next service domain. Networking's most used services are Amazon VPC, CloudFront, and Amazon Route 53. Let us look at them one by one. Amazon's VPC is one of the most used services all along. So what it does, it lets you provision a logically isolated section of the AWS cloud where you can launch multiple AWS services in a virtual network that you define. So you could create multiple subnets in multiple availability zones, and you could launch a lot of services like EC2, Elastic Beanstalk, Opsworks, and also Route 53 and everything. So you could launch all of these services within that, and you can make all of them communicate with each other. Also, another use of VPC is that you could use VPC peering to connect two VPCs together and make them communicate with each other and route traffic across both VPCs. Let us move on to the next service. The next service is Amazon CloudFront. Amazon CloudFront is basically a content delivery network or a CDN. So it is a CDN service that securely delivers data, videos, audio files, applications, and APIs to customers globally. So what it actually does. So for example, there is YouTube. YouTube is a video streaming platform, and YouTube needs a content delivery network to store all of its videos. So what it does is it has an origin server, but it cannot provide all the data to all the users all over the globe from that particular server. So Amazon's CloudFront has multiple edge locations all across the globe. So if there are 3 different end users from different parts of the globe trying to access the same file from the same CDN from the same origin server, for each user the CloudFront edge location will vary, and they request the origin server and get the data and then move it forward to the end user. So this makes the content delivery even faster and secure and better. Now let us see the third service in the networking domain. The third service is Amazon Route 53. Amazon Route 53 is a highly available and scalable cloud domain name system web service. So what is a DNS or a domain name system? Domain name system is like a telephone book for the internet. It stores all the IP addresses and it converts the domain names to IP addresses. So for example, if an end user asks for a website called example.com and the DNS resolver checks it, and if it doesn't have it, it asks to the Route 53 which you have configured, and the Route 53 converts that particular domain name to an IP address and sends it back to the DNS resolver, and that IP address will be forwarded to the end user and he can use that particular IP address to access that web service. So this is all about networking services. Now let us move on with the next service domain. The next service domain is security, and we are going to see about security and identity services here. Okay, there are 3 services which we are going to see right now. The first one is IAM, the second one is KMS, and the last one is Cognito. Okay, so what is AWS IAM? IAM is an identity and access management service. This will enable you to manage access across all the AWS services and resources securely. So what is an access management tool? So consider you own a website. So in that website, you need to provide different people who use your website different accesses. Okay, consider there are 3 main employees who use your website. The first one is the administrator of the website, the second one is the web developer, and the third one is a data scientist. So you have to give your root credentials to the admin, but not to the web developer or data scientist. But you have to provide the web development dashboard credentials to the web developer and the data analytics dashboard credentials to the data analyst or the data scientist. So you can use IAM to create user credentials and also remove unused or stale or unnecessary IAM user credentials. You can restrict the use of the AWS root account to only particular users, and also you could enable multi-factor authentication for all the users so that your website and your data is secure. Now let us see the next service. The next service is AWS Key Management Service. So thus the name Key Management Service, this service is used to create and manage keys and control the use of encryption across a wide range of AWS services and the applications which you have uploaded to the AWS infrastructure. So what a KMS does? First, let me tell you what you will do to secure your data. So you have data and you're uploading it to the AWS infrastructure and you want to secure it. So you create an encryption key for that data. But what will happen if that encryption key is stolen and used? So to provide encryption for that encryption key, you can use CMKs or customer management keys. CMKs are used to encrypt your encryption keys which holds the encrypted data. So you can use CMKs and also enable policies that would use your CMKs and who cannot use your CMKs. So you can mention particular users who could use your customer management keys and the other users who cannot use the customer management keys. This would be very helpful in securing your website. You can also use CMKs to protect your data, but mainly CMKs are used to create encryption for the encryption keys. Now let us move on to the next service. Amazon Cognito is the next service. Amazon Cognito lets lets you add user sign up, sign in and access control to your web and mobile app quickly and easily. This is mainly designed for developers who want to add user access management to their applications and sync it. So what basically happens here? In Amazon Cognito, there are two pools, user pools and identity pools. So what are user pools and identity pools? User pools is an user directory which provides sign up or sign in options for website or mobile applications users. And identity pools provide AWS credentials to grant your user access to other AWS services. So basically what you do is you use Cognito to take the identity credentials from other third-party providers like Amazon.coms or Facebook's or Google's, and Cognito is the middleman who authenticates the user's credibility to use AWS services. And if the user's encryption keys are checked and or verified, then the permissions will be provided to the user, who could use the permissions to log on to the AWS console and use AWS services. I hope you understood security services. Let us move on to the next service domain. The next service domain is management, and under management we will be looking at services like AWS CloudFormation, AWS OpsWorks, Autoscaling, CloudTrail and CloudWatch. The first service is CloudFormation. AWS CloudFormation provides a common language for you to describe and provision all the infrastructure resources in your cloud environment. In simple terms, AWS CloudFormation lets developers and businesses create a collection of AWS resources and services and provision them in an predictable and in the same order in which they want the services or resources to execute. So what is made possible by CloudFormation? Using CloudFormation, you could create a repeated task into a single task which you can use multiple times by just writing a simple code. So what basically happens is you create a code from scratch, or you can use available templates which is already provided by AWS, and then you could code locally or upload it to the S3 bucket. And after that, you can use CloudFormations using the GUI which AWS provides, or you could use command line interface of AWS to create a stack-based application using your template code or using the template which is already provided by AWS. And finally, AWS CloudFormation provisions and configures the resources you have specified on your template. Whichever the resources you have specified on your template, and in the same order, the resources will be provisioned and configured. Using CloudFormation is as simple as creating an EC2 instance. Now let us see the next service. AWS OpsWorks is a configuration management service. OpsWorks provides managed instances of Chef and Puppet. So what are Chef and Puppet? They are automation platforms that allow you to use code to automate the server configurations of your application. Also, what are OpsWorks stacks? OpsWorks stacks lets you manage application and servers on AWS and on-premises infrastructure, so that you can design your application with different layers. That is, you can provide stacks of databases, load balancers and servers as per your wish. That is, each layer of the OpsWorks stack is a different AWS service. Now moving on with the next service. AWS Autoscaling is the next service. Autoscaling monitors your applications and automatically adjusts capacity to maintain steady, predictable performance at the lowest possible cost. So in the simplest terms, autoscaling basically monitors your website's traffic, and when it increases the hardware components it requires, and while the traffic decreases, it decreases the hardware components which is required. Let me provide you a simple example. A company XYZ uses 4 servers and 4 databases for their website, and suddenly there is a peak of traffic in Monday and they require 10 servers and 10 databases. So what they basically do is they try to purchase 6 more servers and databases and install in their on-premise setup. But after Monday, for all the 6 days of the week, they will not be having any traffic and all those servers will be idle, and that will be a huge waste of cost and time. Instead of that, they can opt for AWS Autoscaling, which will only cost you for the servers and the databases or any hardware components you are using currently. And when your traffic increases, it increases your servers and databases needed, and while it decreases, it also decreases your servers and databases needed, and only the particular servers which are used currently will be taken into account. And also AWS autoscaling provides you with two different scaling methods. One is vertical scaling and another one is horizontal scaling. Vertical scaling is nothing but when there is an increase in the users, the server components will be automatically increasing with that. And horizontal scaling is said, and right now vertical scaling is that the number of server components won't increase. Only the specifications or the configuration of the particular server or the database will increase. So for example, you own a server and a database which has a particular capacity, but when the number of users increase, instead of buying more servers and databases of the same configuration or specification, you tend to improve your servers and databases configuration by providing them with more hardware components. That's all is about AWS autoscaling. Let us move on to the next service. AWS CloudTrail is the next service. CloudTrail is a web service that records activity made on your account and delivers log files to your Amazon S3 bucket. If you are using CloudTrail in your AWS account, you can log and continuously monitor and retain account activity related to actions across your AWS infrastructure. So basically you can check what are the services which have been used, who are the users who have used those, and how much amount of services have been used. And also you could store it in your S3 bucket as log files, and you can review the log files later for reporting it. Now let us move on to the next service. Next service is Amazon CloudWatch. CloudWatch is a monitoring and management service built for developers, system operators, and site reliability engineers, and also IT managers. CloudWatch is basically a monitoring service which you use for the AWS resources which you use, and also the applications which you have uploaded and are using in the AWS infrastructure. You could collect the log and metric data of your AWS resources and also the applications which you have uploaded and which is running on the AWS infrastructure, and then monitor your applications and your AWS resources using those collected metric data, and also use that metric data for further business use to add business value. CloudWatch lets your application run smoothly by providing you details of resource utilization and your application's health and performance. CloudWatch could be accessed using APIs, command line interfaces, and also the AWS Management Console. Let us move on with the next service domain. Now we have arrived to the final service domain, which is application services. In application services, we will be looking at three different services. The first one is SNS, the second one is SQS, and the last one is SES. Let us first see SNS. Amazon Simple Notification Service is a web service that enables applications, end users, and devices to instantly send and receive notifications from the cloud. Before telling you how SNS works, let me tell you who are publishers and subscribers. Publishers and subscribers are two clients who use SNS. Publishers are the people who send the message or the notification, and subscribers are the clients who receive or consume the notifications. So how does it work? Publisher sends or pushes the notification and it goes to the SNS topic and stores there. And SNS then filters the message according to the subscriber's needs. If a subscriber doesn't need or subscribe to a particular topic, he won't be sent that particular notification. And only the subscribers who have opted for that notification or that news will be sent that. So there could be n number of subscribers. It could be AWS Lambda, AWS SQS, and also an AWS SES, an email service. But why do people use SNS? SNS provides simple APIs which you could integrate with your applications and use SNS services. And also SNS is a push-based delivery system. So it is very easy for publishers to push their data into the SNS topic and continue to send the messages to the subscribers. Let us see the next service. The next service is Amazon Simple Queue Service. The Amazon Simple Queue Service is almost similar to the notification service, but there are few differences. The main difference is that SNS uses a push mechanism, and because of that, time critical messages are sent through that. And SQS uses a polling model to exchange messages for distributed applications. In SNS, we saw publishers and subscribers, and here the same is producer and consumer. Basically, the producer sends the message and the consumer receives the message. And in between that, a polling model is used that whenever a message is sent, only one message can be sent through the queue. And at a time, only one message can be sent to a consumer or a subscriber. That's all about Amazon SQS. Now let us see the next service. The next service is Amazon Simple Email Service. So we all know what is an email. It is an electronic mail which we use to send messages through the internet. So SES does the same thing, but here it is a cloud-based email sending service designed to help people who market on the internet and also application developers to send their marketing notifications and transactional emails or bulk amount of emails to the recipient. So how does it work? So the sender sends the email. A single email also can be sent or a multiple number of emails. And first it goes to the SES, the simple email service, then pushes the data or the email to the receiver's ISP, the internet service provider. And finally, that ISP will provide the email to the recipient. It is a simple working method which could be easily understood. That's all about application services. Now let us move on. Now we have come to the part of Amazon's pricing models. Okay, come on, let us look into it. So AWS provides three types of pricing options. The first pricing option is pay as you go or pay per use. The second pricing option is save when you reserve. And the last one is pay less by using more. Let us see pay as you go right now. So what is pay as you go or pay per use? So whenever you use a service or multiple services, you only have to pay for those particular services, not the whole infrastructure. So if you use a particular service, say as Amazon EC2 for 20 hours in a period of 2 months, you won't be charged the amount for 2 months. You will only be charged for 20 hours which you have used. That is very easy and cost effective for any business or a personal user. The second option is save when you reserve. You could always reserve instances in Amazon Web Services. By reserving instances, you have the ability to launch the amount of instances or the number of instances whenever you want until the period which you have reserved those particular EC2 or any instances. Also, when you reserve a particular number of instances, they are reserved for you so that you would get up to a 75% discount sometimes. And also, you could change the configuration of the reserved instances whenever you want. Now let us see what does pay less by using more means. So we all know when we go to a shopping mall and if we purchase a lot of products, we might get a discount more than we expect. So the same thing goes with AWS. Amazon Web Services provides you a lesser price or they provide you discounts when you use a lot of services. If you are provided with a 20% discount for using 100 instances of AWS resources, if you use 500 instances, you might be given more than 25 to 30% of discount. Now that's all about pricing options. Let us see the next topic. Next topic is free tier. AWS provides a free tier for a year. Also, the services are always free and available for anyone. If you create an AWS account right now and the moment you created, after that you have free services for next 12 months, but they have limitations. Also, you could use few software solutions as a free trial and check out whether which particular service or which particular software solution is suitable for your business needs. So also, AWS provides a free usage of Amazon EC2 up to 750 hours every month for 12 months. Also, the same goes with Amazon S3 and Amazon RDS. But Amazon DynamoDB is always free. You could use until you want to stop using AWS, and it is always free, and up to 25 GB of AWS DynamoDB storage space is given to you. Also, AWS provides you with a simple monthly calculator. This can be used to calculate the amount of expenses which you have spent on particular services and finally add them up. Using this calculator is very simple, and they have provided all the options and all the documentations and blocks you need to start with this. So if you are an AWS user, please check this simple monthly calculator so you could calculate all your expenses. Okay guys, we've seen a lot of theory concepts till now, and let us see a practical concept. That is, we are going to create a demo and host it on AWS. We are going to do a hands-on right now. And what is going to be the use case? The use case is very simple. We are going to host a website and it can upload and download files which can be either PDF, docs or image files. And also using Amazon Web Services, we are going to create the databases and storage buckets to upload the files. Before going inside the project, let me give you a brief explanation of how we are going to do this. So there is a user who enters an URL or an address inside his URL locator bar in his browser. So our website will be loaded there, and we can use that website to upload files to the file server and database and also download it back. Let me show you how our application works. Okay, so this is the application which I have created. So you can use this application to upload a file and also check whether that available file is there. Okay, so to give you a small example, let me upload this file number 2 here. I'm opening it and I'm uploading it. So the file has been uploaded successfully. That is, it has been uploaded to the database. And in the download page, you can see number2.pdf and its size and the download numbers, and also download and uploads location available. Also, I can download these files. See, and this downloaded file will be stored inside the uploads file inside the demo. We all know that in XAMPP server, any projects folder will be inside htdocs, and here inside htdocs I have created a folder called uploads, and I have given that path in order to store these files. Let me show you whether it is available in the database or not. Okay, so I have used the root credentials to come inside, and I have used the database which I have created, which is upload, and also I have selected the star from files which is showing the last time which I tried. So right now I'm going to try it again, and here you can see the updated one. So this is the basic functionality of a application, and let me explain the code a little bit. Okay, so this is the main page, this is the index.php, and I am linking filelogic.php here. Also, it contains a simple form with a typed file and also a submit button. So while you press the submit button, which has the name save has been taken because I've given method is equal to post there. So save will be taken and this code will run. So what it basically does is it takes the file name, it takes the file size, it allows PDF or docs or JPG extensions. You can also upload zip files. Also, it doesn't let files to be larger than 1 MB. And then it uploads to the file to the destination path. So here we are using a SQL query, which is we are uploading name, size, the download and location. Also the values are $file name, $size, 0 and upload /file name. It is 0 because initially the downloads value is 0. Also, if it is uploaded successfully, we'll get the message file uploaded successfully. If it is not, we'll get file failed to upload file. And this is for the download part. So the file ID is taken and select start from files where ID is equal to $ID. So a particular ID of that SQL database tables will be taken, and from that table files, if my file's ID is 1 and I want to download that will be downloaded here, and it takes a file path. If the file exists, it automatically downloads it to this path with the file name, and it updates the query. It also updates whenever you click on download, it will get uploaded and the downloads value will go up by 1. Let me show you the downloads file also. Downloads file is a simple table. It contains table headers as ID, file name, size, downloads, action and location, and it contains a for each loop, and in that for each loop every time been made, it will get uploaded here. It will get updated by this. It takes this ID, name, size as the SQL files attribute names. Okay guys, before moving further with AWS, I'll show you the last time when I created a hosted site for the same application. So here it goes. My address is intellipaat.ml. So here you can see the same structure has been uploaded, and here you choose a file and you upload this. upload, and the file has been uploaded successfully. You can see it in the download page, and you can also download it. So already there are two files existing in that. These files exist in the RDS instance of the AWS services. Also, it gets uploaded to the S3 bucket. Let me show you how to do this one by one. Open your AWS management console first of all. Okay, so I have already logged into my account, and this is my account. So the first thing we are going to do is launch an EC2 instance. Also, we are going to create an RDS instance. It is a database instance. Then after that, we will create an S3 bucket to upload our files there. Let us start with creating an EC2 instance and connecting it. Okay, now there are 0 running instances. Let us launch our first instance. So I'm going to choose the AMI as Ubuntu server because I'm going to run my files on Ubuntu. Then uh, this is a demo, let us choose free tier eligible. Always choose free tier eligible options because this is just a demo. So for testing, that is more than enough. So this is configuring instance details, and here they are creating they are not creating, there is already a default VPC available, a virtual private cloud. And then we are moving further and adding storage. The size is 8 GB and that is more than enough, and it is root. Then adding tags are not required, and configuring the security group. We are creating a new security group here. So also we can add a custom rule so that we are going to launch it on the browser with that IP address. So for that to run here without the firewall intervening, we have to create an anywhere for the port range 80. And now let us review it and launch it. Just check it once and launch. And also you have to create key pairs. That is, if you don't have an existing key pair, you have to create a new one. So key pairs are basically you will be provided a private key which will match with this public keys, and after that the encryption will be decrypted and you will be allowed access to this. So let me give you the name for this key pair, and I'm giving it as Intellipaat. So I'm downloading the key pair and keeping it right there. Okay. So I'm launching the instances now. So this is going to take around 2-3 minutes. So let us check the other things. So go to this folder where this is available and check the folder where it is available, and it should be accessible for you, because if you lose this file, you're going to lose your entire EC2 instance and your data on it. Okay guys, now the instance is running, and now let us create a .ppk file for PuTTY, because PuTTY doesn't accept PEM files. So I already explained why we use these files. They have a public key and we will be given a private key, and private key will be used to decrypt the public key so that we get access to it. So let us load our PEM file here. So the PEM file is available in downloads. Okay, so in downloads files, you can see it, but instead of ppk, you have to give it as all files, so that, and you can search it here. Okay, so here the file is, and we are going to open this. And Region takes it and just give OK, and it is going to convert this file into a ppk file. So you save this private key and save it in a place which you can access very easily. So without this, you cannot access your EC2 instances. So I'm going to store this ppk file here, and I'm going to name it as the same name as I gave for the PEM file. So I saved it and I'm closing it. So it's still running. So now we are going to connect this instance. So to connect this instance, what we have to do? We have to take this IP address. So first let me run and show you. So it won't connect because the EC2 instance is not running. So let me connect the EC2 instance. So you have to give this particular public IP here, and after providing the public IP, we have to upload this ppk file here. So after that, just give open, and you will receive a PuTTY terminal and give yes, So they'll ask login as, and the common ID for this is, username for this is Ubuntu. And right now you're logged into a Ubuntu instance, a Ubuntu EC2 instance. So right now, first thing we have to do is we have to update this instance. Okay, after updating, we have to install a web server called Apache 2. So we are installing Apache 2 right now. We are using Apache 2 to run our PHP files in this Ubuntu server. So this is the way to do it. And always provide sudo in front of your commands so that it takes the admin permissions here. Okay, so it has been uploaded. So let me show you the example right now. So I'm going to take this again and paste it here. And now you can see file running here. This file is index.html, which is inside the Apache 2 folder in Ubuntu EC2 instance. So we are going to change this file into our PHP file. So let me show you how to do that. So let us go back to the root folder, and right now we are in the root folder, and there is a file called where, and we have to proceed into that. So where, and here there will be a file called www. So, and then here there is a file called html, and here we can see index.html. So what we are going to do is we are going to upload our files here instead of index.html and making our file run. So let me do that first. But before trying to do that, we have to install PHP first. So to install PHP, you have to give this. And also you have to check what version you're going to use. If you have used PHP 7.2 in your local host, please download the same file here and install it. Now we have installed PHP 7.2, and after that we also have to install PHP's Apache 2 library. So to install that, we need this commands, and also we have to install MySQL, which supports PHP 7.2 in Ubuntu. So we're going to paste that here, and these are the commands. And also you have to make this PHP to PHP 7.2 so that PHP 7.2's MySQL APIs are downloaded, and hit the enter button. Okay, now all the required installations are done. So right now we are going to upload our files into this particular path, and after that we are going to remove index.html and then run our index.php file in this. So how to do that? First you have to open a text editor. So you have opened this. Now we have opened the index.php file here. So what we are going to do is we are going to copy the file content from our local host, the file content which we have used. But I have made a slight change here because instead of 3 files, I have used 2 files here. So my file contents are available here. So I'm going to open this and see I have reduced the file content to 2 files, and I have just implemented, instead of calling file logic, I have implemented the file logic inside index.php and inside downloads.php. So what I'm going to do is I'm going to copy all of this file content and I'm going to paste it in the EC2 instance. So I have pasted now. So I'm giving Ctrl O and then enter and Ctrl X. And after that, I have to create the downloads file. And inside the downloads file, again, I'm going to do the same thing. I'm going to open the downloads file, copy the content and paste it inside, and Ctrl O, enter, Ctrl X. So we have done this. So after that, also we have to create a directory uploads, because we are using an upload files and an upload files path in order to save our files in that. So we are going to create a folder called upload. After that, We are also going to create a folder for called AWS because we have to implement all the AWS API keys here. So let me explain you what is AWS APIs for PHP. Okay, so AWS PHP API. So AWS SDK for PHP. And what we have to do is download this AWS PHP. PHP is a zip file, and what we are going to do is we are going to curl it there. I've created the AWS file, so I'm going to go inside the AWS directory, and here I'm going to curl this link. To curl it, you have to provide this particular attribute, and also you have to provide the file which this particular zip file is going to be available in. So now the file's download has been completed, and now you can see an aws.zip file. So to unzip this, you also have to download and install a software called Unzip. So now Unzip has been installed, so you can use Unzip. Okay, we've used Unzip to unzip all the contents from that aws.zip file, and here you can see all the available content. We are going to use this content to inside our PHP code. We are going to use this AWS PHP API keys, and we are going to use these PHP files and the AWS PHP SDKs to build our code. Now let me go out of this. Okay, so now we have everything we need. We have the AWS folder with all the AWS PHP SDKs, and we have the downloads.php file, the index.php file, also the uploads folder where the uploaded files are going to be uploaded. Now to proceed with this, we have to create an RDS instance and an S3 bucket. We have included that in this PHP files code in order to upload it to the S3 bucket and the downloads folder. Let me show you how to do that. I have come again inside this AWS management console, and right now I'm going to choose the service RDS. So I'm going to RDS. So there is no DB instances running currently, so we are going to create a database. We are choosing MySQL because we are using MySQL in our local host. And also we are enabling only options which are used for free usage tier. So I'm providing next. So it has to be t2.micro so that free tier is enabled. So I'm going to provide identifier as MySQL instance. My master username is going to be Intellipaat, and my master password is going to be Intellipaat123 and Intellipaat123. So next. So now I'm creating a new VPC security group here, and I'm not preferring anything here. So this is not that much important. So right now what we have to do is we have to give our database a name. So I've given the same name as the database which you have created in the localhost as upload. And after that, I'm going to remove this thing because we don't need snapshots in our AWS management console right now because this is just a demo. Okay, after checking everything, I'm going to create this database. So to create a database instance, it takes around 2 to 3 minutes. So let us create an S3 bucket in the same time. I'm going to open S3 here. And after opening S3, we are going to create an S3 bucket named Intellipaat. You can see here already there are two buckets available. So what I'm going to do is I'm going to delete this bucket. So what we are going to do now is we are going to create a new bucket. I'm giving the bucket's name as Intellipaat2, and after that I'm providing next. And also we don't need to see this that much because we don't need a tag. Also make sure all of these are checked and then give next. And after that, if you want to review it once, review it and then provide create bucket. But before that, I'm changing my region to Virginia because each region in this AWS management console has a different code. So I have used North Virginia's code here, so I'm going to use this. So I'm providing next. So now I'm going to create the bucket. See, now bucket Intellipaat 2 has been created successfully. So you can see here a bucket has been created. Also here, I think the MySQL database will be running. So it is still in the creation process. So let us wait for some more time. Okay, now our database instance is available. So what we are going to do is, so I'm going to use this endpoint in order to connect with the database. So now I'm going to the EC2 instance and let me see. So downloads.php, index.html, index.php and uploads and AWS directories and files are there. So what I'm going to do is I'm going to open index.php. So what I'm going to do here is I'm going to copy this particular and paste my code, paste my endpoint. So I have pasted my endpoint here. We're going to use this endpoint for this MySQL instance to connect with our database. So what I'm going to do is I'm going to edit the code according to this. So I'm going to close all the unwanted files here and I'm going to keep only these two files. So this is the endpoint of the previous RDS instance which I used. So I'm going to change it with the current RDS instance and I provided my username as Intellipaat and my Intellipaat and my password as Intellipaat123 and my database name is upload. So I'm going to use the same thing. So I have put it here and also I'll also explain the S3 code while I'm doing it. So right now we'll do only this. So here also we have to change it because I'm connecting with the database instance twice. So I have changed the code here also. So what we are going to do right now is we're going to remove the index.php files, create a new index.php file which has the current instance. So I'm going to copy this and paste it here. Control O. After that, I'm going to now create the downloads file. And then once again, first remove the downloads file and then clear. So I'm removing the downloads file first. So after that, I'm opening again a downloads file. After creating a new downloads file, I'm going to paste that edited code here and I'm going to save it and close this. So now we have both the files which we require. Also we have created the S3 buckets name as Intellipaat 2 because my S3 code has the Intellipaat's file name as Intellipaat 2 here. So now let me explain you what happens here. So when the submit button is clicked and save is off. So here the file name is taken, the destination path is taken, and what is this? This is the AWS autoloader.php which we require to run PHP files using S3 buckets, because to connect both S3 and PHP we need these APIs and PHP files. So also here we are creating a new S3 client and providing its region, its version, and also the security credentials. And what I'm doing is I'm going to put an object inside the S3 bucket. So to put that object to that, we need three attributes. The one is bucket name, the second one is key, that is the file name which you have already mentioned, and the last one is the source file, the destination file. And this is the downloads code which I already explained to you. Now let us move on. So what we are going to do right now is we are going to try to run it. So before that, we have not created any tables inside this new RDS instance which we have created. So how to connect your RDS instance with your local MySQL shell? Let me show you that. First of all, let me open the shell which I have opened the local database in. So this is the local database, and here you can see the database and the tables inside the database and the files which have been uploaded, or the entries which have been updated here. So to connect an RDS instance, the first thing you have to do is open another shell, and you have to use the same commands which you have used here as MySQL, and the username and the password. You have to use the same thing there, but two attributes will be included there. The first one is port number and the second one is endpoint. So let me show you how to do that. Open a new shell. So first it is MySQL, and my username which I've given for that RDS instance is Intellipaat, and the password I don't need to give it right now. I can give it later when I click on enter. And the port number is 3306, and you can see the port number over here. And the next field is endpoint. So I'm copying this endpoint value, and I'm going here, and you have to give -h and paste it. And right now you have to enter the password. The password which I entered was Intellipaat123, and I've given enter, and now I am logged into this RDS instance which I have created. So here you can see the databases which are available. So these are the databases which are available, and upload is the database which we have created while creating the RDS instance. So first thing we have to do right now is we have to create a table for this database. So first let us use this database. After using it, now we have to create a table. So to create a table, we have to use the same table and the same fields, the same attributes as how we created our local database. I have already told you how to create a table and also the query to how to create a table. So now let us create a table. So to create a table, we have to use the command create table and the table name, and after that we have to give the attribute. So instead of wasting time by typing all that, I already have it typed up over here. So let me just copy it and paste it over here. And we have created a table now. So let me show you the table. So there is a table files available, and it will be an empty set. So what we are going to do is we have already changed the code according to this endpoint. So if this RDS instance is running with this table available, so obviously the code which we have stored in the EC2 instance, the index.php or downloads.php, will run. So let us try by running them. And we know how to run that. We have to go take its IP address and just paste it in the URL tab. So we know how to run the EC2 instance. We just have to take the EC2 instance IP address and paste it on the URL tab in the browser. So let us do it now and check whether the database and the S3 bucket is getting updated. And if we do that, our project is complete. Just we have to create a Route 53 hosted zone and host it online. So right now let us see whether it's running or not. I'm just going to the Okay, so now we can see our website is running over here, and this is the local one, and this is the EC2 instance website, the PHP file. So this is the index.php file. So right now let me upload a file and show you how it works. So let me upload AWS 1, and I'm uploading it, and the file has been uploaded successfully. And let us go to the download page and check once. So here we are receiving it. So AWS 1, the size is 9 KB. It has been downloaded 0 times. Then the download button is over here, and also the location is provided. This location is the location which is in the EC2 instance. So right now let us check and confirm whether the data has been updated. Let me go to this. Now again I'm selecting start from files, and right now you can see an entry has been made because we have uploaded a file. So also let us check in the S3 bucket whether the file is uploaded there or not. Let me refresh it, and you can see here also the AWS 1 file has been updated here also. So our project's objective has been complete here. So what we have to do now is we have to create a Route 53 hosted zone in order to host our website online. So let us do that. Now you could say that our website is running completely on AWS services. Our websites in PHP files are running on EC2 instances, and our database is on RDS, and the storage bucket we are using S3. So now let us start with Route 53. So now we are going to start with Route 53, and before starting that we will get a free domain. We will purchase a free domain in order to run our website on that particular domain. So to get a free domain, you could go to freenom.com and you could sign in this and you could get a free domain for yourself. I have signed in right now and I already have a domain available. But let me get a new domain so that I could show you how to do Route 53 and how to host our website online. So let me type the name which I want as the free domain. So I'm typing Intellipaat here and I'm giving enter. I have received multiple domain names for this name Intellipaat. So I'm going to go with intellipaat.tk. I'm trying it now. I've selected it and I'm going to purchase it. So I'm going to go to checkout. This intellipaat.tk domain name. So I'm going to use this domain name to host my IP address on that. So what I'm going to do is I'm going to first create a Route 53 hosted zones. So first I'm going to manage the domain here. So I'm going inside this domain and I'm going to the name server. So what we have to do is we have to create a Route 53 hosted zone and take the name servers which it provides, and we have to change the name servers over here. So that is what we are going to do. So let me show you how to create a Route 53 hosted zone. So we have opened the Route 53's homepage. So I already have a hosted zone which I created for this intellipaat.ml file. So domain name. So I'm going to create hosted zone for our intellipaat.tk. So I'm creating one. I'm providing my domain name which is intellipaat.tk, and it has to be public hosted zone, and I'm going to create it. So you can see here you have two values. This is the name server value. So what we have to do is we have to copy this name server values and paste it over here. So we have to do that with every single name server. So there will be 4 name servers available. So we have to do that for each and every one. So I am done pasting now. So also please remove the dot which is available here. So it is not actually required, and save the record. And right now we have to create 2 record sets so that our website, when we type intellipaat.tk, it should run. Also when you type www.intellipaat.tk, it should also run in the same time, because we are going to provide our IP address inside 2 created record sets. So the first record set is going to be intellipaat.tk, and it has to be IPv4 address, which is the type A, and you don't need to create any alias. So what you have to do is you have to copy this IP address, paste it over here, and HTTP, it should not be there. It should be just the plain IP address. So what you have to do is just create it, and now create another zone, another record set, and provide www.intellipaat.tk and paste the same IP address here and create it. So we have given here, and right now we have to change the name servers here. So the intellipaat.tk domain is active now, and we have also created so that we redirected this IP address to this Route 53's values, that is to these domain names. We have redirected the IP address to these domain names. So whenever a person searches this domain name, the DNS resolver will check for this, and if it is not available, it will check to the Route 53. So if it is available in Route 53, it will give back the IP address so the user could use it. So now let us try whether a website is running or not. So in Route 53, for a website to get hosted, it will at least take 3 to 5 minutes. So if you're doing this right now and if your website is not hosted immediately, don't panic, because take some time and check it again. So now let us check whether Intellipaat.tk is online or not. So I'm typing Intellipaat.tk. So you can see here the website is running. Also, you could check by providing www.intellipaat.tk, and the website runs now also. So let me upload one more file for your clarification. Let me upload it, and so it has been uploaded successfully, and I'm going to the download page, and you can see the 3.pdf file. Also, you could check it here. The 3.pdf file has been updated. Also, I'll show you whether it has been updated in the S3 bucket. So the S3 bucket has been updated with 3.pdf. So right now we have created a complete website by hosting it on using Route 53 and using S3 bucket to create a storage a bucket, and also we have used RDS to run MySQL on it. And finally, the first thing we did was creating an EC2 instance so that we could run these index.php and download.php files, so that you could use that IP address to create a website to host. And finally, we got a domain name and we hosted it. This is the complete demo, and this is the complete hands-on which we have done. I hope that you have understood all the concepts which I have explained here and all the 4 main AWS services which we have used. So now let me show you how this is layered, and finally we'll do a knowledge check by reviewing few questions which you have learned from this AWS tutorial. I'll be asking you a few questions and you have to answer them, and you could comment that down later. So right now let me show you how the layer has been implemented here. So you could see this. The user is you or me, and Route 53 is the DNS resolvers. So the user is you or me, or it could be anyone, and Route 53 is used to host that IP address using a domain name. So we did that right now and it got online immediately. So if it doesn't get online for you, just wait for some time and check it again. So after that, Route 53 IP address redirects to the EC2 instance. So from the EC2 instance, to connect to the RDS and the S3 instances, we have to provide security credentials, and I showed the security credentials in the PHP code which I showed you in the beginning of the video. So using that, we are logging into the RDS instance and the S3 instance. Okay guys, we have come to the end of this video. In this AWS tutorial video, we have learned a lot of information about AWS and its services. Also, we did a demonstration on how to migrate your local application to the AWS infrastructure. So I guess you have learned a lot about it, and let us do a knowledge check right now. To start off, let me ask you a simple question. What does cloud and cloud computing represents? This is a very simple question, and I guess you could easily answer this, and the answer is internet. Moving on with the second question. The second question is, how large can a single archive be? Archive in the sense it is the S3 Glacier archive. We all studied about S3 Glacier. S3 Glacier is used for data archiving and data backing up. So guess what can be the single archive's largest size could be? Let us see the answer. The answer is 40 TIB. Moving on with the next question. The next question is, what type of queuing system is Amazon SQS? This is also a pretty simple question. We have discussed it recently, and we have discussed about what is SQS, SES and SNS. And I think you know the answer for this question, and the answer is distributed system. And moving on. The fourth question is, if a company wants to use the DNS web service, and what is the appropriate option for them to use an AWS service? So I have told you what is a DNS resolver and what is a service which is provided by AWS for this particular option. So I guess you have guessed it already. It is Route 53's hosted zones. And finally, the last question is, which is Amazon's CDN service? CDN is a content delivery network. So the answer for this question could be found in the networking service domain part, And also, please leave a comment below. Okay guys, now we have come officially to the end of this video. Okay, that's all for today. Also stay tuned for more videos on Amazon Web Services. Hope I helped you and have a great day.